Here we go through an example of RAG with a StreamNative Pulsar cluster using Pulsar functions, using OpenAI for our vectors, the Milvus connector and Zilliz database for doing the storing the vectors and doing the similarity search, and then finally using AWS Bedrock with Meta's Llama 3.2 to summarize the data that was returned. We're going to break this up into 3 videos. The first video is going to go through the creating of the vectors and putting them into Zilliz using the Milvus connector. The second is going to be triggering some sort of workflow where you need information out of the Zilliz database using a similarity search. So we'll first take that information, create an embedding out of it, and then complete the similarity search and write that to topic SIMOut1. And then finally, in a third video, we're going to use Amazon Bedrock with Meta's Llama 3.2 to take the results of our similarity search and summarize them. That could then be sent out to a customer with the information that's relevant specifically to them. So let's start by deploying embed 1. I'm going to go over here to the create and sync embeddings, OpenAI and Milvus Zilliz connector. And I'm going to take this pulsar cuddle functions create command and deploy that. So here in terminal, I'll execute that code and we'll deploy embed 1 pulsar function. After waiting a minute or two, here in the UI, I can see that embed 1 is running. Next, we need to deploy the Milvus connector to sync these embeddings into our Zilliz database. If I go over to the connectors tab, Kafka syncs, I'm going to say create Kafka sync, and then click on the Milvus sync connector. I'm going to call it my sync and choose a service account that I know has the correct permissions and binding. There's more information in the course on that. I'm just showing quickly here how the total flow of this workflow works. I'm going to paste in the endpoint for my Zilliz cluster, and then I already have an authentication secret here. That is the token that you get out of the Zilliz UI. The collection name I'm going to use is called my collection. And the topic name I need to use is going to be the output topic of the Pulsar function we just deployed. And since this is a Kafka connector, the tenant and namespace and topic need to be separated by a period instead of a /. One additional change I do need to make based on the way I have set up my schema is I need to actually turn it off. And for value converter configurations, for values converter schemas.enable, we're going to say false. At this point, I can go ahead and click submit and deploy that connector. After waiting a minute or two, you should see that my sync shows a status of running. Here I am in the collection, my collection, in my free cluster on Zilliz. You can see the schema that I've used to define that. There's some very specific information in the course on how to deploy this, so you'll need to follow that. But in data preview here, I've already have some examples that have been uploaded. So to test our workflow though, I'm gonna go ahead and upload 2 pieces of information related to dogs, and then we're going to do a similarity search with dogs. So to trigger the Pulsar function and the sync connector that we just deployed, I need to write a message to input topic 1. We should see that this has one message that is processed through it, and then I'm going to actually go look into Zilliz to check if the number of vector embeddings has increased. So we have 4 right now from some previous testing I did. So let's use the REST API to write to input 1. So first I'm going to write to our input 1 topic a message, dogs like being taken on walks. Next, I'm going to process a message through dogs come in many breeds. If I take a look at my Pulsar function embed 1, you'll see that 2 messages made it across. Next, I'm going to check in my Zilliz database to see that these 2 vector embeddings have made it there as well. And here in the collection, my collection, you can see that there are 2 new vector embeddings, dogs like being taken on walks and dogs come in many breeds. So you can see how easy it is to get any information vectorized and put into a Zilliz database so that we can now complete a similarity search on it, which we'll do in the next video.